So this is the first flip video for Calc 1, and what I will do is I will try to give an introduction to the concept of limit. Um, now let's take a look at this function x squared minus 1 divided by x minus 1, and suppose you want to find the limit of this function as x tends to 1. So you want to find the limit of this, and you want to find the limit of that as x goes to 1. That's how we write it, okay, of this function. Which function? X squared minus 1 over x minus 1. Now what do you mean by the limit? We want to check what happens to this function when you put values which for x which are close to 1. Now remember, it's only close to 1. You cannot really put x equals 1. Why? Because if you put x equals 1, you get 1 minus 1, which is 0, and 0 in the denominator, which is not allowed. So we want to find out values which are close to 1, and then okay, so now look at this table, right? What they've done is, now when you put 0.9 for x, then if you use your calculator, then you can show that the value of this when you put x equals 0.9 will actually be 1.9. On the other hand, that is before 1, but if you put slightly before 1, if you put something slightly after 1, then you get 2.1. And then if you get more close to 1 from, say, from the left side, so if 1 is here, and if you're trying to get close to 1 from the left side, you get 0.99, okay, and then you get the value 1.99. Suppose we want to get to 1 even closer, say 0.999, then you would get 1.999. So if you approach from left like this, you will see that it is getting very close to what? It's getting very close to 2. The value of the function is getting very close to 2. Can you see that? 1.9, 1.99, 1.999, 1.99999. That is if you approach it from the left. On the other hand, if you approach it from the right, 1.1, 1.01, 1.001, once again it's coming towards what? 2.1, 2.01, 2.001. Now the first question to answer is that, are we ever touching the value of 1? In the sense, are we plugging in 1 at all? No, we are only coming close to 1. And what about the function value? The function value is also getting close to 2. So now we can say that as x becomes close to 1, the limit of the function is actually 2. So that's the concept of the limit. We observe the behavior of the function as x becomes very close to a certain value. Now, if every time when we want to find the limit, if you want to do this analysis using calculators, it is going to be very painful. So we will learn a short way of doing this a little later. But for the time being, remember the concept of limit. It is what happens when x gets close to 1 from the left or from the right. But what happens at 1 is not important. Close, that's the idea. We are not really plugging in 1. We are only looking at the behavior as it goes close to 1. Now if you look at another example, now take a look at this graph. This is the same function that we described in the previous example, only thing now it's given as a graph. Now we notice that at 1, this graph has a hole. Can you see that hole right here? Okay. So we have a hole in that graph at 1. Right here. That means the function is not defined at 1, as we learned in college algebra. But Can we still find the limit as x tends to 1? Yes, because what happens at 1 is not important. Okay, so let's try to approach 1 from the left. We are only approaching, we cannot hit 1. Why? Because there is no function. So when you're approaching 1 from the left, you can see that the graph is approaching what? The y value, right? The y value is approaching 2. So it goes like that. This is approaching 2, right? And if you approach 1 from the right, 2. Okay, if you approach from the right, also the y value is approaching from where? So if it is here, then it's here, then it's here, then it's here. It's coming towards slowly and slowly, it's heading towards what? The same value 2. It never really hits 2. So remember, even though there is a hole here, the limit is 2. Okay. Now what about this function right here? Now in this function there is no hole at 1. It's filled, but we don't really care because what happens at 1 is irrelevant. Now even in this function, if we approach 1 from the left or from the right, okay, if we approach it from the left, where is it heading towards? It's heading towards 2. And if you approach it from right, it's heading towards 2 also. So for this function also, the limit would be 2. So both these functions have the limit as x goes to 1, the limit of this function is 2. There is a hole in this function, there is no hole in this function. So that means this function is defined at 1, this function not defined, but we don't care because for the limit we are not interested at what happens at 1, only when it gets close to 1. So just check to see what happens when you get close to 1. Do not look at what happens at 1, whether it is defined or not. Let's do that example. So now here we have 3 examples, again the same thing. So what happens when you get close to 1? Goes to 2. Now this is an interesting example. Now the value at 1 is actually not 2. What is the value at 1? The value of 1 at 1 is 1. Okay, can you see the little darkened thing? So then sometimes when I ask what is the limit of this function as x goes to 1, people say, oh gee, here is 1 and the value is 1. So is the limit equal to 1? No, that is wrong because we don't really care what happens at 1. We are only interested in what happens as it approaches 1. So when it approaches 1, what happens? To approach 1, it actually approaches what? 2. We are not concerned about what happens at 1. At the approach 1 from right, it again approaches 2. So the limit is still what? The limit is 2, not 1. 1 is wrong because 1 is the value at 1. We are not interested in what happens at 1. Now in this one, once again, what happens at 1 is not important. Whether we approach from left or right, it is going to 2. So in all these 3 examples, the limit is equal to 2. Now here are some other examples, but let's take a look at this example, for example. All right, now if you take a look at this function. Now we are interested in finding the limit as x approaches 0 this time. Okay, x approaches 0, not 1. So when x approaches 0, what happens? Now if you approach 0 from the left hand side, what is happening to the function? The function is like that. So the function is heading towards 0, right? So from the left it is heading towards 0. From the right, Where is the function heading towards? If x is approach from the right, look at the function. The function is 1 1 1 1 1 1 1. So from the right, the function is heading towards 1. So once again, when x approaches 0 from the left, the function is along the line goes to 0. But when you approach x from the right, the function is actually going to 1. So from the left, the function goes to 0. If you approach 0 from the right, the function goes to 1. It goes to two different values. Two different values. So this is a problem. If you want to have a limit, no matter whether you're approaching from the left or whether you're approaching from the right, the function must go to only one value. Like in the previous example,